fellow mathematicians, welcome back to another video. Quadratic functions yet again, and if you want to learn more about quadratic functions, make sure to check out the link at the top of the description as well as the info box. Playlist to quadratic functions, everything in there that you're ever going to need, so definitely make sure to check it out. And most importantly, check out the last video I did in the series about completing the square, because it's the basis for what we are going to do today. So let me recap it a little bit. We took a polynomial x squared plus x plus 1. It is something in a monic form, a quadratic function in a monic form. It really doesn't matter if you have a general form like this. And what we did is we did some algebraic manipulations to turn this into something binomial formula plus another something. But what we didn't talk about yet is the fact that this form that we got for this monic polynomial is actually the so-called vertex form of it. And if you ever see the vertex form during your exams or something, you might want to say, oh hooray, this is very good, because this vertex form is going to tell you basically everything you need to know about a quadratic function already, which is really good, and this is what we are going to talk about today. And at the end, a few Desmos insights, because there's some stuff that we need to take into consideration when talking about the vertex form. And now we are going to dive right in. So suppose we had this generalized form of a quadratic function, or maybe a monic form. And what we can do using completing the square is we can turn this quadratic function into something of the form f of x being equal to, it really doesn't matter if it's stretched or not, we are going to get an a in front, that's the stretching factor, and then x minus something, whole thing squared, plus another something. This happens after you go through the completing the square process. This is what we are going to get out, and this right here is the jackpot. This is very good, because the d and the e that we have in here, they are the x and y coordinates of the vertex that we have talked about before. Okay, simpler case is when we don't have any movement to the left or right of the coordinate system, then our d is equal to 0, giving us something of the form ax squared plus e. And well, we know how to handle this, because this right here is just a function that's shifted upwards and downwards in the coordinate system, giving us a vertex at the spot 0 and e, meaning our e is our y-intercept. So taking the analogies from the cases we had before. And well, the y-intercept is in our case also the y-coordinate of our vertex, meaning this right here can also be denoted as y with a little v down here for vertex. And our d that we're having here, only the d, not with a negative sign, is the x-coordinate of our vertex. And now we are going to take an example that we had before, namely the function f of x is equal to x squared plus x plus 1. And what we did in the last video is to transform this into this function, namely x plus 1/2 squared plus 3/4. And those two functions are both the same, okay? You can just factor everything out and land at this function again. But the way better thing here is we turned this normal form, this monic form, into the vertex form. I want you to see the similarities here, namely this right here is in a monic form, namely the leading coefficient is a 1, okay, makes sense, our a turns into 1, meaning we don't have anything in front of our parentheses. Then we have x plus something, okay, x minus something, nearly the same, squared, plus some e at the back. And once you have this form, you can just read off the vertex at a glance. Namely, what is the vertex? Where does it lie in the coordinate system? Let us start with the easier part, namely the y-coordinate. Our y-coordinate is just what we have at the back, and it really doesn't matter if there's a negative 17 here or 3/4 like in our case. Just read off what you see here. Namely, 3/4 is the y-coordinate. It's as easy as this. But what about the x-coordinate? The x-coordinate is the thing that most students have a lot of problems with, because sines, and students don't like sines in the normal case because they confuse the shit out of them all the time. Now here is the thing, we have a plus 1/2 in parentheses right here. But if we take a look at the vertex form, we need a negative sign in front. That's a bummer, right? I mean, we are so close to finding out what the x-coordinate is, but there's this negative sign here. How can we get a negative sign in front of our 1/2? For this, I want you guys to think back to the playlist on sets of numbers, because on the integers we said that we can turn a plus into negative sign basically by saying that a positive sign is nothing but negative times negative. Hey, This is pretty good, right? I mean, positive 1/2 is nothing other than negative 1/2. And this is exactly the trick that you need to use here. Now rewriting what we have in parentheses here turns this into x minus negative 1/2. And now we have exactly what we need. We have a negative d, with our d being exactly negative 1/2. And that's it. This is where our vertex lies in the coordinate system. And if we just put the vertex in here, okay, let's say this right here is negative 1/2, this right here is going to give us 3/4, then our vertex is going to lie here. Now you can take your monic or parent function ruler if you have something like this in the United States too. For example, we have a certain ruler where you can sketch it onto a piece of paper. You probably have stuff like this too. You can put it at the vertex point and then you are basically done. Oh, that's a nice looking parabola. And then you are basically done sketching it into a coordinate system. And now you are pretty good off because you can see now, there's a 0 and there's a 0 of this function. This is good. No further calculations required if you can just read off the zeros nicely, for example. And here, this is why the vertex form is actually so good, because you can see the vertex at a glance, okay? Basically, if you see the trick with the negative signs here, and then you can just sketch everything into coordinate system, which is very nice. Fingers, with the negative sign here, there's a simple mnemonic device that you can use. What you are basically going to do is you are going to take a look at the sign in front of your d. For example, in our case it was a positive sign before, and every time you want to read off the x coordinate you are just going to take the other sign, okay? If there's a positive 1/2 here, your vertex is going to be at the x coordinate negative 1/2. If there's, for example, a negative 16 here, then there's a negative in front of your d, meaning you are going to get a positive sign in front of it, positive 16. And exactly this trick is what we want to practice a tiny little bit, okay? In the following examples, let's say we have a function g of x being equal to 2 times, and then we're going to have x plus 7 squared minus 1/2. And now we want to read off where the vertex lies in the coordinate system. By the way, we are going to take a look at the Desmos insights in a few minutes from now, because we didn't really talk about the a right here. I never talked about, does the a even affect our vertex? I mean, I just now put an a in front, meaning we converted basically a generalized form into a vertex form, but does it affect our vertex in any way? And I say no, because it really doesn't. And this is for the Desmos part. I want to visualize this a tiny little bit. So just take it for granted for now that this a really doesn't affect where our vertex lies in the coordinate system. Now, at first, what we are going to do is we are going to read off the y-coordinate, because this one is way easier to read. Now, our y-coordinate is just what we have at the back right here, negative 1/2. Now, what about the x-coordinate? Oh, now we have a positive 7. And like I mentioned before, if you have a positive sign here, just take the inverse sign on your 7, namely negative 7, and this gets the job done. Just because of this reason right here, that positive is nothing but negative times negative. Now what about this other example, h of x is equal to, let's say, negative 4, and then we're going to have x minus 1/4 squared plus 17. Okay, where's our vertex now? Where is your vertex now, my son? Okay, so 17 is just our y-coordinate. This is really easy to read off. Now what about the x-coordinate? Okay, so we have a negative sign in front of our d, basically, meaning we need to take the inverse sign. Negative becomes positive, so positive 1/4, and hence we are done. And here, this is basically all you need to do, okay? Once you transformed a general form or monic form into a vertex form, all you need to do is read off what's at the back. This is your y-coordinate of the vertex. And then the d in here with the switched signs from negative to positive or positive to negative is going to give you your x-coordinate of the vertex. And now we are going to take a look at Desmos, and then you are going to see that our a in front, our stretching factor, scaling factor, really does not affect the position of our vertex in the coordinate system. Now what I did is I just simply plugged the function that we just now had into Desmos, and now I can put a few levers in here that I can switch around, tiny little bit, shift around. And now you're going to notice if I place it at some spot in the coordinate system, our parabola, let's say at -3 and 1, okay, then our vertex form is basically going to be something of the form a times x and then +3, because negative times negative is positive, squared, and then +1. And now what happens if I make our a from 1? It's a normal parabola, a parent function at the moment. If I take this parent form, monic form, and turn it into something with an a greater than 1, for example. Oh, our parabola is going to be stretched, but the vertex really doesn't change. What happens if I squish it a tiny little bit between 0 and 1, our a? Okay, nothing happens to the vertex, this is good. What about if I turn the parabola upside down, if it's open to the downwards y direction with a negative a? Really doesn't change anything. I mean, yeah, this is good. And this is exactly the point that I was talking about before. Our a really doesn't affect where our vertex lies in the coordinate system. And this is pretty good. And yeah, just keep this in mind. The only important things are your d coordinate and your e coordinate that we talked about extensively during this video. If you did enjoy this video, please like, subscribe, make comment, channel, like if you want to support support the channel a bit more, buy those t-shirts I create, a support channel on Patreon. And up until next video, I wish you guys a flammable day. Please stay safe. Ciao.